Hi, in this Unity tutorial, I'll be showing you how to implement a simple dash mechanic. Let's look at how our player is set up before we go into any scripts. The player uses a rigid body with a capsule collider for physics and collisions. An audio source and audio listener are used to play sounds, and the particle system is used to create a dash trail effect. The player also has a player input component from Unity's input system, along with the player script that controls all of this behavior. In our player script, we first define all of our references that we will need: the rigid body component, the particle system, the audio source, and finally the emission module of the particle system. The first three we assign in the inspector, and the last one we assign on awake. Next, we define the settings: move speed for the base player movement speed, dash speed for the speed that the player dashes with, dash decay speed for the amount the dash loses velocity over time, dash particle rate for the amount of trail particles emitted over a distance, and finally the dash sound for the audio clip that is played when the player dashes. Lastly, we define the state variables: the move input vector and the dashing boolean that stores whether or not the player is currently dashing. Next, we have two input methods defined that get called by the input system: onMove and onDash. OnMove handles basic movement input. It reads it to the input vector from the input system and stores it in the move input variable, mapping the x value to the horizontal movement and the y value to the forward movement. The input vector is already normalized, so no additional processing is needed here. OnDash handles the dash input. When the dash action is pressed and the player is not already dashing, it starts the dash by enabling the dash state, activating the trail effect, and playing the dash sound. It then immediately sets the rigid body's velocity to dash speed in the player's forward direction. The last method in our player script is the fixed update method. It handles player movement and the dash behavior every physics frame. First, we calculate the player's input movement velocity by multiplying the movement input by move speed. The player is then rotated to face the direction they are moving. Next, we handle dashing. If the player is currently dashing, we compare the rigid body's current speed to the normal movement speed. If the current speed is still higher than the input movement speed, the dash is still active. In this case, we gradually reduce the velocity using dash decay speed and exit the method so normal movement does not override the dash. If the current speed is no longer higher than the input movement speed, or if the speed is below a certain threshold, the dash has ended. We set the dashing variable to false and stop the trail effect by setting the emission rate to 0. We use square magnitude instead of magnitude because magnitude uses a square root call, which is really expensive if ran every frame. This works in our case because we don't need the exact value and we can work with squared values instead. Finally, if the player is not dashing, we apply the normal movement velocity to the rigid body. We also have a script attached to the camera called SmoothFollow, which makes the camera smoothly follow the player. The script stores a reference to the target it should follow along with the follow speed. On awake, it calculates the offset between the camera and the target so the camera keeps the initial distance. Every frame, the camera smoothly moves towards the target's position, adjusted by the offset, using a lerp based on the follow speed. Now that we have taken a look at our script, let's go to Unity and see how everything is set up. In Unity, let's take a look at our player input component first. The input action asset has two input actions: move and dash. The action type for move is a value and the control type is vector2. Next, we have a composite binding, which is a vector2, and then the mode is digital normalized. What this does is it automatically normalizes the input values and we don't have to do that manually in our code. Then we have all of the four composites of our vector2 up, down, left, and right, and they're binded to W, S, A, and D keys. Next, we have the dash input, and it simply listens to the space key. In our player script component, we reference the rigid body, which is this one. We reference the trail, which is this GameObject right over here, which has a simple particle system I have created. Next, we reference the player audio source, which is the player GameObject itself. And we have some settings which I have set right over here, and I have put in a simple dash sound that I found online. Now let's see how playing with our settings changes the behavior of the player. So let's change the movement speed first. And this is our base movement speed. It's currently set at 6, and if we increase it, you can see that the player moves much more rapidly. So let's undo that. Let's take a look at our dash right now. So this is the basic dash speed. And if we increase the dash speed, so let's say 64, you can see that the player dashes much further. Now let's increase our dash decay speed to something like 128, and you can see that the dash lasts much shorter. We can also increase the dash movement speed, the initial movement speed, and as you can see, it dashes much further, much faster, but it also stops sooner because the dash decay speed is increased. Let's undo this and put defaults in, and let's increase the last thing, which is the dash particle rate. Let's do something like 8 for now, and as you can see, there's much more particles, and if I put 1, there's fewer of them. If I just set it to 0, there won't be any dashing particles. Thank you all for watching. I hope you learned something today. If you have any questions, feel free to leave them in the comments below, and I hope you have a nice day. Bye bye.